A matrix is given to you. We have to find out the eigenvalues and eigenvectors of the given matrix. You know the characteristic equation A minus lambda I inside the determinant multiplied by x equal to 0. Here x not equal to 0. Therefore, determinant A minus lambda I equal to 0. Just we have to subtract lambda from the principal diagonal elements and then we have to take the determinant. Determinant of A minus lambda I, which is equal to determinant of 2 minus lambda 2 1 1 3 minus lambda 1 1 2 2 minus lambda should equal 0. Now we have to simplify this. 2 minus lambda into just leave this column and this row. 3 minus lambda into 2 minus lambda minus 2. Then minus 2 into leave this column and this row. 2 minus lambda minus 1 plus 1 into leave this column and this row. 2 minus 3 minus lambda equal to 0. Now you have to simplify this. This is 2 minus lambda 3 into 2 6 minus 3 into lambda 3 lambda minus lambda into 2 lambda minus 2 minus plus lambda into lambda square minus 2, then minus 2 into is 2 minus 1 1 minus lambda plus 2 minus 3 plus lambda, and that is multiplied by 0. Now you have to simplify this further. Now we can write 2 minus lambda 6 minus 2 4, then minus 3 lambda minus 2 lambda minus 5 lambda plus this lambda square. Here minus 2 into 1 minus lambda. So this is minus 2 into 1 minus 2 minus into minus plus 2 lambda. Here 2 minus 3, that is minus 1. So minus 1 plus lambda equal to 0. Now multiply this. 2 into 4 8 minus 2 into 5 lambda 10 lambda plus 2 lambda square, then minus 4 lambda into 4 minus lambda into 4 minus 4 lambda minus into minus plus 5 lambda square minus lambda cube plus 2, this is minus 2 plus 2 lambda minus 1 plus lambda, entire is equal to 0. Now we have to align the terms. Minus lambda cube. Next align the lambda square terms. 2 lambda square plus 5 lambda square, that is equal to plus 7 lambda square. Next come to the lambda term. Minus 10 lambda minus 4 lambda, that is minus 14 lambda. Here 2 lambda plus 3 lambda, that is equal to minus 11 lambda. Allowing the constant terms 8 here minus 2 minus 1, therefore plus 5, which is equal to 0. Now the above equation is changed as lambda cube minus 7 lambda square plus 11 lambda minus 5 equal to 0. Now we have to solve this equation to find the eigenvalues lambda 1, lambda 2 and lambda 3. Now we have to factorize the equation. This is lambda cube, lambda square and lambda term constant term. Lambda cube 1, lambda square minus 7 and lambda term plus 11, constant term minus 5. 0 here. To cancel this, we need plus 5 here. So put 5 here. 1 plus 0, 1. 1 into 5, 5. Minus 7 plus 5. Minus 2. 5 into minus 2, minus 10. This is 1. 5 into 1 plus 5. That's 0. Here, the value of lambda 1 is equal to 5. We have had the first eigenvalues. Furthermore, we have had an equation. That equation is lambda square minus 2 lambda plus 1 is equal to 0. Now we have to solve this. Lambda square minus lambda plus 1 is equal to 0. This minus 2 lambda is written as minus lambda. Then lambda, take out lambda outside. Lambda into lambda minus 1. Here take out minus 1 outside. Lambda minus 1, which is equal to 0. Then if you take this lambda minus 1 as a common term, lambda minus 1 into lambda minus 1 is equal to 0. If lambda minus 1 equal to 0, then lambda equal to 1. Or this factor lambda minus 1 equal to 0, then lambda equal to 1. So the values of lambda 2 and lambda 3 are lambda 2 equal to 1, lambda 3 equal to 1. So these are all the eigenvalues. The eigenvalues of the given matrix A are lambda 1 equal to 5, lambda 2 equal to 5 and lambda 3 equal to 1. Lambda 1 equal to 5, lambda 2 equal to 1, lambda 3 equal to 1. Now we have to find out the eigenvectors. To get the eigenvectors, we have to use our eigenvalue equation. A into x equal to lambda into x. This is the general equation. For the first eigenvalue lambda 1, we have to write A into x1 equal to lambda 1 into x1. Here couple x1 is the eigenvector. The value of x1 is x1, x2, x3. It's a column matrix with 3 elements. We have to find out the values of x1, x2 and x3. Here lambda 1 is 5. Now take the matrix A, 2, 2, 1, 1, 3, 1, 1, 2, 2. The next one is small x1, small x2, small x3, which is equal to lambda 1 is 5. 5 into x1, x2, x3. This is 2x1 plus 2x2 plus x3. Then x1 plus 3x2 plus x3. Then x1 plus 2x2 plus 2x3, which is equal to 5x1, 5x2 5x3. Now we have to correlate the things. Just written the equations separately. 2x1 plus 2x2 plus x3 equal to 5x1. x1 plus 3x2 plus x3 equal to 5x2. x1 plus 2x2 plus 2x3 equal to 5x3. From this equation, see here 2x2 plus x3 which is equal to 3x1. 5x1 minus 2x1, 3x1. Here x1 plus x3 equal to 2x2. Here x1 plus 2x2 equal to 3x3. With the help of this, take this equation. In this equation, instead of this 2x2, substitute this value x1 plus x3 equal to x2. 2x2 is x1 plus x3. Instead of this 2x2, we have substituted this value x1 plus x3 plus this x3 equal to 5x1. We know that x1 plus x3 equal to 2x2. So in the first equation, instead of 2x2, we have substituted x1 plus x3. Now 2x1 plus x1 is equal to 3x1. x3 plus x3 is 2x3, which is equal to 5x1. Then 2x3, which is equal to 2x1, because 5x1 minus 3x1 is 2x1. From this, x3 equal to x1. In the above equation, the value of x3 equal to x1. This is the first conclusion I arrived. Then, in this equation, x1 plus x3 equal to 2x2. Instead of x3, we may put x1 because x3 equal to x1. Now this equation becomes x1 plus x1 because x3 equal to x1, which is equal to 2x2. Then 2x1 equal to 2x2. Therefore, x1 is equal to x2. From these two equations, we may conclude that x1 equal to x2 equal to x3. Put x1 is equal to 1. If you put x1 equal to 1, x2 equal to 1, x3 is also 1 because x1 equal to x2 equal to x3. Now the first eigenvector x1 equal to small x1 x2 x3 which is equal to 1 1 1. Suppose the value of lambda, that is eigenvalue is 5, the characteristic vector of this matrix is 1 1 1. Now we have to go for the next eigenvalue, lambda 2 equal to 1. You know the value of lambda 2 which is equal to 1. Use the general formula A into x2 equal to lambda 2 into x2. A matrix is here. Once again, we have assumed the value of x2 as small x1, small x2, x3, which is a column matrix with 3 elements. Then the value of lambda 2, second eigenvalue equal to 1. 1 into x1, x2, x3 is 2x1 plus 2x2 plus x3, which is equal to 1 into x1, x1. This is the first equation I have. Then from this, x1 plus 3x2 plus x3, which is equal to x2. Then x1 plus 2x2 plus 2x3 which is equal to x3. We have had three equations. Now we have to solve all the three equations. From equation 1, from this equation, if you bring this x1 to the left hand side, we can get x1 plus 2x2 plus x3 equal to 0. From this equation, we can get x1 plus 2x2 plus x3 equal to 0. Same equation. If you bring this x3 to the left hand side, x1 plus 2x2 plus x3 equal to 0. We have had the same equation. Here, put x3 equal to 0. If you put x3 equal to 0, you can get x1 plus 2x2 equal to 0. Here x3 equal to 0, therefore x1 plus 2x2 equal to 0. Then x1 is equal to minus 2x2. Put x2 equal to 1. Therefore, x1 equal to minus 2. If you put x2 equal to 1, x1 equal to minus 2x2. Therefore, x1 is equal to minus 2. x1 equal to minus 2, x2 equal to 1, x3 equal to 0. Now, the second vector becomes the value of x1 is minus 2, the value of x2 is 1, x3 is 0. This is a characteristic vector of the matrix A corresponding to the eigenvalue of 1. The third eigenvalue, lambda 3, is also 1. So the value of x3 is also minus 2, 1, 0. Or we may present the value of x3 in another one form. To get the value of x3, even though lambda 2 and lambda 3 are different, if you want to present the value of x3, which is entirely different from x2, consider x2 equal to 0. If x2 equal to 0, we can have x1 plus x3 equal to 0. In this equation, x1 plus 2x2 plus x3 equal to 0. Put x2 equal to 0. If we substitute x2 equal to 0, we can get x1 plus x3 equal to 0. Then x1 is equal to minus x3. Put x3 equal to 1. Then x1 is equal to minus 1 because x1 is equal to minus x3. Now the third vector x3 becomes the value of x1 is minus 1, x2 is 0, x3 is 1. So this is the third vector corresponding to the eigenvalue lambda 3 equal to 1. Sometimes we may write x1 equal to 1, 1, 1, x2 equal to minus 2, 1, 0, x3 also minus 2, 1, 0. If you want to present the value of x3 that should be different from x2, then make our assumption that x2 equal to 0. If you assume x2 equal to 0, automatically x1 is equal to minus x3, then we can have another one vector x3 which is different from x2. Or otherwise you may present x3 also minus 2, 1, 0. That is also correct. With respect to our expectation, we may provide our substitution for x1, x2 and x3. So the eigenvalues of the given matrix are matrix A are 5, 1 and 1. Eigenvectors are x1 equal to 1, 1, 1, x2 equal to minus 2, 1, 0, x3 equal to minus 1, 0, 1.